Yes, I'm going to show you how to make a tower that has a branching base to it. And this can be used in the case of a base, but also really any part of a branching component of a tower. We're going to start from a fairly basic tower that has an origin point, an ellipse. That ellipse is then moved along a set of series, and then that series of ellipses are lofted. We're just going to quickly make to create the branch, we're going to quickly make an XYZ vector. And this is going to be, start informing what the branch is going to be. So if we put the series into Z and then put the vector into the move, we basically are going to end up with two lofts on top of each other. In this case, though, if we set an expression for the Z value, negative Z, we then have a part of the tower that's extending below. Now, in this case, I'm going to be using the exact same series, but you can create a separate series for this as well. That way, you could have a tower that has, perhaps the branching part isn't exactly the same as the not branching part in terms of floors and height. That can be done for the purposes of the exercise. We're just going to leave it as it is. So we have this vector module. So we're going to kind of create a graph mapper to be able to start informing the x and y components of this. And we're just going to hook this up to the x and hook it up to the y. And we get this very sharp angle, and that's because we haven't started manipulating the graph mapper. So if we go into the graph types, and I'm a big fan of Bezier, so let's use that. And then double click again to set the values. If you've seen my other videos, you know that I think the best way to set values for this is to multiply these two numbers. Basically, the inputs of the series gives you the most easily manipulable values. Nothing really happens at first, but if we start manipulating this a little bit, you can start to see we get a little bit of a curve, and we start maneuvering this handle as well. You start to get something that looks a little architectural. We want to leave this point there. That way we're sure that the ellipses match up. Once we start moving this, then the base is kind of out of sync of the tower. So we're going to make sure that that's in the bottom corner. Now from here, all we're going to do is rotate this tower. Now this is kind of a little bit of a cheap workaround. If you look at my other video, you can see that there's a little bit of an easier way to go, but I just wanted to show multiple ways of accomplishing a similar thing. If we go ahead and we rotate this, we need to create a series of this rotation. So we're going to use the series we already have just as a base point. We're going to manipulate this again. Bring that over to the rotate input. Let's go ahead and manipulate the expression here. If you type in rad a, that changes the radians input into a typical degrees input, which I'm a little bit more used to seeing. I'm going to bump up this number here, the m input, a lot, so we can start to really have a whole lot of range of what kind of angles we're dealing with. It didn't quite work the way it should have. Let me try that again. Upper limit 180. Commit changes. Now we're talking. So you can start to see we're getting all sorts of different bottom branches. If we scale this number down a lot, this is basically going to act as the number of branches we have. Something like 4 or 5. Then you can tweak and play with the bases you want. Now, the base is set below the ground zero plane. The quick workaround for that is to create a multiplication module that takes the tower dimensions series, multiplies them together, and uses that as the basis of the Z of the origin point. Now this is a quick approximation, but it'll get you with a branching tower.